All right, so let's start. Okay, so we start with line integrals. Let's see be a bounded continuous parametric curve. And we assume that C is piecewise smooth with piecewise smooth parametrization RT. By VT, we denote its velocity vector. Then the arc length of this is just the integral of speed, right, over the time interval AB, and this is nothing but x prime t, x prime t squared plus y prime t squared plus z prime t squared, z prime t squared. Okay. This is the arc length, and we have also the following. If let's say S, let's say, okay, şöyle diyeyim. If ds represents this quantity r prime t dt, then we may compute the mass of the curve, let's say considered as a wire, if the density, if its density is given, let's say rho x, y, z, let's say gram per santimeter. Diyelim ki bu curve'ün bize işte şey verilsin, yoğunluğu. Şurada bir ds aldığımda, so ds is an arc length element. It is basically the length of this piece. If I multiply this with rho, the density of this piece, then I will get the mass of this piece. And integral of this, for example, integral from a to b, rho, here I have x, y, z, but here I should plug rt there, and then ds, this will be the mass of the wire. Değil mi? Diyelim ki suppose that the density is a function of position, okay? It changes from point to point. So the integral will be just the total. Okay. Let's see some examples. Okay. Calculate C y ds, where C is parameterized is r equals rt, and it is a times cosine t times I plus a times sine t j. So this is a plane curve, and t is ranging from 0 to pi. Okay, so we have a plane curve. And what is this? Well, you see that the x coordinate is just cosine, y coordinate is sine. So this is nothing but a parameterization for a circle of radius a, right? This is r0, which is just a, and this is r pi, which is minus a. So this is just semicircle, and we are asked to compute this function, this integral. So what is ds? So r t is just a cos t, b sine t. Let me write it this way. Then r prime is just minus a sine t, b cosine t. So what is ds? ds is just r prime, norm of this, not a, both of them are a sine t, a cosine t, right? Derivative is this. Norm of this, what is the norm of this? Uh, so r prime t dt, so this is just, okay, a squared sine squared plus a squared cosine squared, and then we have dt. So this is just a dt, because sine squared plus cosine squared is just 1. So ds is just a dt. Our integral was integral over this y d s. Okay, now c is the parameterized curve where t is ranging from 0 to pi. So the meaning of this is just integral from 0 to pi y. What is y? Well, y is just, so this is x comma y, right? X comma y. Y is just a times sine t. You may consider this like as density, and then ds. What is ds? ds is just a dt. So this is just a squared 0 to pi sine t and then dt. So this is just a squared minus cosine t 0 to pi. So this is minus 1, another minus 1, but you have minus sign in front already. So this is just 2a squared. Okay. Okay. Another example. Find the centroid of the circular helix CG. given by r rt, which is just a t cosine t I plus b sine t t plus btk, where t from 0 up to 2 pi. Okay, so what is this? This is helix. This is an helix. So something like, okay, something like this. Çok iyi çizemedim ama işte değil mi? Bir silindirin üzerinde helix. Centroid dediği bunun center of mass'i. Okay, centroid. Center of mass. Assume that it is homogeneous. Assume that it is homogeneous. Meaning that the density is uniform. In other words, the density is uniform. Yani noktadan noktaya değişmiyor. Center of mass has 3 components. Centroid. It has 3 components. mx, my, mz. What are these? Where center of mass'i nasıl bulursunuz? X'in integrali, y'in integrali and mz. Yani şöyle düşünün. Suppose you have something like this. How would you find the center of mass? You just write take okay. Bir dakika. Okay. Evet. Yani mesela şöyle olsaydı, şöyle diyelim ki işte şurası x ekseni, şurası x eşittir 1, 2, 5. Center of mass'ı nasıl bulursunuz? Değil mi? Bu kütleleri neyse bunu, diyelim ki bu A olsun, bu B olsun, bu C olsun. Ne yapardınız? So from this is x equals 0. You would just A times 1 plus 2 times B plus 5 times C. Değil mi? Sonra da bunu şeye mi bölerdiniz? Toplam uzunluğa, değil mi? Yo. Yok. Toplam kütleye bölersiniz, değil mi? A plus B plus C'ye bölersiniz. Okay. So if you had just three, point masses here, then the center of mass would be just A times this, B times 2 times B, 5 times C divided by total mass. Okay, so this is what we are doing here. Assuming if if the mass is uniform, then A, B, C are the same. So A. So I have A. Therefore, we have just A is gone. So 1, 2, 5 divided by the length. Okay. All right. So center of mass will be then just this quantities divided by the length of the object. Okay, so let's see. Bunları hesaplayalım. Mx x okay. İlk önce şeyi bulalım. Peki, of course, rt is just what was it? A times cosine. Oh, this is also A. I am sorry. These are A. So this is okay. A cosine t, B, no, A sine t, B t, B t, okay. T from 0 to 2 pi. So R prime t is just minus A sine t, A cosine t, B. Therefore, ds is just norm of this dt. So norm of this, square of this, plus square of this, plus square of this. So it will be just a squared b squared dt. Okay. All right. So mx is just the integral over c x ds. X is just, so integral from 0 to 2 pi. X is a cosine t, and then ds is just a squared plus b squared dt. These are constants, so I can take them outside. A times a squared plus b squared, and then integral of cosine, well, it is just sine t, and then this is from 0 to 2 pi. Well, if you plug 2 pi and 0, you just get both are 0. My is just y ds 0 to 2 pi a times sine t, and then a squared b squared dt. So the same thing, a times a squared b squared. This time we have minus cosine t, 0 to 2 pi. When I plug 2 pi and 0, I get both 1, but since there's a minus sign between the two terms, this is again 0. And mz is just z ds, 0 to 2 pi. Z is just bt, değil mi? Bt. Yani şöyle diyeyim. Okay, this is x, y, z, right? Dt is a squared b squared dt. So this is just b times a squared b squared, and then integral of t, which is just t squared over 2, 0 to 2 pi. So this is just 0 koyunca 0, bunu koyunca 4 pi kare, 2'ye böldük. 2 pi kare, 2 b a kare artı b kare p squared. So center of mass will be how much? I have to also find uh, arc length. Arc length. Arc length is 0 to 2 pi ds. Well, this is just a squared b squared dt. I'm sorry, 0 to 2 pi. So this is just a squared b squared times 2 pi. So centroid is then centroid bu değil de divided by arc length olacak. Ver. Değil mi? Bunlar yani gibi, açısal momentumlar gibi. So it is mx, my, mz divided by arc length. So it is 0, 0, and this is neydi? Mz 2b a kare artı b kare pi squared divided by 2 pi times a squared plus b squared. You divide by this constant, so you get 0, 0. 2 pi gitti, pi gitti. Bir de bu gitti. Ne kaldı? B çarpı pi kaldı. Bu da gayet doğal tabii ki. Aslında hesaplamaya bile gerek yok, değil mi? Neden gerek yok? Bu dikkat ederseniz aslında you take a circle and cut it here and then you just do this, something like this. Yani şöyle mi olacak? Yani 2 pi kadar açıyorsunuz. Buradan kesip 2 pi kadar açıyorsunuz. Şöyle çizemiyorum düzgün ama neyse. Yani şunu circle olarak yapacağım. Şöyle. Sanki şöyle, evet. Okey. Circle'ı bir noktada kesip iki ucunu 2 pi kadar açıyorum. Tamam mı? Center of mass'i x ve y koordinatında değişmiyor. Yani orijinde, hala orijin. Z koordinatı da homojen olduğu için toplam yüksekliği neyse onun yarısı olacak. Burası 2 pi kadar. Çünkü 2 pi b kadar. Yarısı da pi times b olacak. Tamam mı? Okey. Şimdi bu 960. Okey. Ondan sonra hangisi varmış? Vector fields and scalar fields. Bu aslında scalar field integralini yapmış olduk. Scalar fields. So what is this? Okay. A function, uh, let's say f from a region R into real numbers where R is a region in R3 is called a scalar field. Yani bir tane elinizde region olsun. Aslında illaki bir region olması bile şart değil. Mesela şöyle bir şey var. Bunun her bir noktasına burası R olsun. Her bir noktasına x, y, z. I assign a real number. Okay? This is a real number. Something like this is called a scalar field. For example, this function could be the temperature. Okay? The density. F can be the temperature. Doğru yazamıyorum değil mi? Temperature. Mass or ne olabilir? Başka basınç olabilir. Pressure at the point x, y, z. Mesela atmosferde bir noktadaki hava basıncı olabilir. Değil mi? Sıcaklık olabilir, şey olur. Bunlara scalar field diyoruz. A function f from R into R3 or R2 uh, depending on R is a subset of R2 or R3 is called a vector field on R. For example, let's look at this one. Let's take this region to be just R2 and fxy to be the following. Let's say xi plus yj. What is this? Well, this is a vector field. At 0, it is 0. At the point xy, what is the value of this vector field? Well, if this point is xy, then the value of this vector field xy is just actually x comma y. So I represent this as follows. I just take this vector and attach to this point. So this is a vector field. This is called radial vector field. At any point, its magnitude is just not it is just given by again xy. So if you keep if you are away from the origin, then of course the magnitude will increase, right? If you are close to the origin, it will be small. So that's why this is called the radial vector field. It gets bigger and bigger as you get away from the origin, right? At the origin, it is 0. For example, on the unit circle here, on the unit circle, let's say take a unit circle here, then at any point it is just this, right? If you choose a smaller circle, then it's like this. So as you approach to the origin, it gets smaller and smaller. That's why, and the vector is just the vector at the point xy is the vector xy. Another example is, let's say this is example 1, example 2. Again, let's say R to be R2, and this time gxy is just this. Minus y comma x. So minus y I plus x times j. What is this? You see, minus y comma x and x times y is just 0. It means this is perpendicular to the position vector. So if you are at a point xy, then this vector is, so this is your position vector. The value of your vector field is perpendicular to this one. So this is fxy. Minus y comma x fxy. This time, these vector fields are tangent to this circle, okay? And as the radius gets larger, the vector field gets larger, okay? This is called, that's why, tangential vector field. This is called a tangential vector field. Okay. Another example in R3, let's say, suppose we have a mass m at the origin, then the gravitational vector field field induced by M is given by, right, f x y z. This is minus k times M r minus, okay, let's say at the point r0, point r0, so r0 norm squared, yok kübü olacak, r minus r0, where r is just x, y, z, and r0 is x0, y0, z0. So we have a point mass at any point. So this is the point r0. At any point r, the vector field is given by this formula. So if I write it in coordinates, so this is km times, and then x minus x0 squared, y minus y0 squared, z minus z0 squared, and then here I take 3 over 2 or third power of this norm, and then here I have the vector x minus x0, y minus y0, z minus z0. So this is a force in the opposite direction to the vector r minus r0, and it gets bigger and bigger as you approach to the mass, right? If you are away from the mass, it's small, but if you get closer and closer to the mass, it gets bigger. Similarly, we have electric charge and so on. Okay. Another example, gradient vector fields. What are they? If phi, let's say, okay, R2, R3, R2, R is a function where R is a domain, is a region. R3'te de olabilir, R2'de de olabilir, is a region. Then F, which is gradient of phi, is defined to be the following vector field. You just take its derivatives with respect to variables. If it is just two variables, x and y, then I have just this much. But if we have three variables, then we have this. It's called the gradient vector field of the function phi. Okay. Şimdi burada birazcık diferansiyel denklemlere de girmiş ama biz o kısımları yapmayacağız. O zaten sizin daha sonra differential equation'da göreceğiniz şeyler. Onları atlayacağım. Şimdi gradient, divergence and curl'den bahsedeceğim. Gradient'ı zaten söyledim. Bu da 16.1'miş. Yani burada sadece tanımları vereceğim. So scalar field is just a function, real valued function. Vector field, vector valued function. Okay. Vector can be a measure of velocity, can represent velocity, acceleration, force. It can be electromagnetic force, gravitational force, or some external force. Scalar fields are just some functions which may represent temperature, pressure, or density, or potential. Okay, gradient, divergence, and curl. We already gave the following: if f x y z is a differentiable function, is a function whose first derivatives exist, then the gradient vector field grad f is defined as, demin yaptık değil mi? Gradient of f is just f sub x, f sub y, and f sub z. Okay, so this way we obtain from a scalar field a vector field. So hence if f is a scalar field, so it's a function, real valued function, then its gradient is a vector field. Okay. What about divergence and curl? Okay. Divergence and curl. Take any vector field f, f r is in R3, let's say, or R2. O zaman tabii bunu da R2 alacağım. Say f'in komponentleri şöyle olsun. F x y z is f1, f2, f3, or f1 I, f2 j, and f3 k. I can write it in either way. Uh, then divergence of f is defined to be the scalar field given by, yani divergence f bir scalar field şöyle tanımlanıyor. Divergence of f. You take the first component of the vector field and differentiate with respect to the first variable, and then you take the second component, differentiate with respect to y variable, and take the third one, differentiate with respect to z, and add them up. A notation for this is the following. We write it this way. So we write, this is just a notation, nothing but a notation. Consider this as a vector and take dot product with f1, f2, f3. So when you take dot product, del x of f1, which is this gadget, del y of f2, this gadget, and del z of f3 is this one. Okay? So this is just a notation. But it's a convenient notation. Okay? This is called divergence. So divergence takes a vector valued function, a vector field, and gives you a scalar function. So it turns vector functions to scalar functions. Hence, divergence f is a scalar function, scalar field. Zamanı geçirmişim. Let me stop here and give 10 minutes break.